Hi guys, I did this water battery the other day. Got a copper plate and a magnesium plate. That's the anode and cathode, and they're running this clock. So it's producing, I don't know, a couple of volts thereabouts. And I had a question from Becky. Would it work with Jell-O? Well, in the UK, Jell-O is not quite so easy to get hold of, but jelly, I believe, is virtually the same thing. Cost me a whole pound, that did. So have we got any instructions? There we are. Separate into cubes, place in a jug or a bowl, add half a pint of boiling water and stir till dissolved. Add cold water to make up to a pint. Well, we don't want a pint. We just want enough to fill that. Yeah, cold water, stir, then pour into the mould or serving dish. Allow to cool and then refrigerate to set. What I plan to do is take the lid off, empty it of water, fill it with Jell-O, and then put it back on again, see if we get any conduction or any battery effect with the Jell-O. I suspect it might work a little bit while it's still in a liquid form. Might, because there'll be water in the circuit, and as we can see, it works on water anyway. That's just plain water in there, or tap water. But whether it'll keep working when it sets, I don't know. So we'll set the tripod up so we can actually watch what we're doing, and then we'll give it a go. Right, I don't think there's any way we need a full pint of this. I'm going to pour the water out of that into this measuring jug and see how much water it is. I'll be surprised if we've got even half a pint. So we're going to have to halve this or less. Right, you will observe the timer stopped. Stick that in there. Well, that's a surprise. That's the half pint mark. That's about 3/4 of a pint. Sorry, not 3/4. 3/8 of a pint. Half would be 4/8. That's about 3/8. And we want to do half of that first with hot water to mix it up, and then top it up with about the same amount again to cool it down. So the most we need is a half of this. Let's just have a look at that in fluid ounces instead. It's 8 fluid ounces we managed to get in there. So half of 8 fluid ounces is 4 fluid ounces. So we want 4 fluid ounces of hot water. That light's flickering. Sorry about that. 4 fluid ounces of hot water, which is less than half of that. And then another 4 fluid ounces of cold water. Right, these used to have measuring marks on them, but they've worn out. So I'm just working out 4. So that's how much we want in hot water. You might hear a clicking. I've got something in my pocket that's rattling. I'll just take it out so it doesn't make so much noise as we're walking. That's what's in my pocket. A bunch of granddads. Just get some cold water again. Right, that's dissolved it. Just put that on there. Yeah. Now we add the cold water. Pour that into there. And then see if we got anything when we put that in there. Yes. Okay. So that is what I expected to happen. That as soon as we put that in there, it is running, because basically that's a water mixture. And we'll leave it and see if it continues to run when it's cooled down. I'll tidy away my bits and pieces. Well, it's been running for 3 minutes. What I'm going to do now is set the clock to the correct time, if I can remember how to do it. Right, 7:44 p.m. That back there. What I really should have done was made that so it would fit on top of there. There we are, set up in the window ledge. So we'll keep an eye on it, see what happens when it sets, because it's still liquid at the moment. See if it still runs. For the jelly to set, I should really put it in the refrigerator to cool it down. But I want to run a time-lapse camera on it to see if and when it stops conducting electricity. So I'll leave it in the window ledge and set a time-lapse camera on it to run overnight. In the meantime, you can see the prices of Jell-O on eBay. Crazy prices. I can get jelly for £1. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.